Kelch comes from Germany. He's the Director of System and Application of System Germany. And he's going to talk about the effect of new published standards, 12.101, on practical implementation.
Okay, yeah, difficult now to start again, but yeah, a warm welcome also from Germany. But Germany isn't as warm as here, so I like to be here for a longer period of time. But unfortunately, I fly in today and out tomorrow, so regulation about pressurization systems. There are many confusions over the last years. These are some pictures of a project that we can share later on it. Control panels. This is a project in Düsseldorf, Trivago, for example. It's 18 levels, as I remember correctly. So, but the interesting thing, we have, or the authorities has made on the pressurization systems a little bit chaos because they splitted these in two different chapters. Yeah. It's not like smoke extract fans, 12.101 part 3. There, exactly the hardware, the testing from the high temperature fan is be fixed. The same they try now, or they do now, in pressurization system, but they split it in part 6. That means part 6. This is the hardware, the testing, the same as a high temperature fan, how to test, what you have to fulfill. F300 means 300 degrees, 90 minutes, F400, 400 degrees, 2 hours, and so on. Then we have the second part, it's part 30. Part 30 only explains how to calculate the volume. That means part 6 is the hardware, part 30 is the calculation, how to calculate the volume to fulfill the velocity and pressure in the building. And we speak about part 6. When we speak about part 30, the only thing what you have to fulfill is in the staircase for this door who is open at the level where there's a fire to create here a velocity that no smoke can go into your staircase. Then your escape route is safe and everything is fine. This is part 13 to calculate the volume for this door. That's all. It's not as easy as you think because the door has a different size. You calculate with, let's say, 2 meters per second. That's the easier part. But then you have leakages on each door. You have maybe a high-rise building with temperature difference, with stack effects and all this. So at the end, it's more physics than you think. But part 6 gives you the hardware to fulfill this. If you calculated then the volume for this, then you can go in part 6 and then you can select a kit. There are complete kits certified that you can then select for your building. The building can be there, either you overpressure your staircase and push out the air, the smoke out of the building like this. Also you overpressure your firefighter's lift. This is a picture from the regulation. So that means supply fans. Have a look for the staircase. It's the air goes either into the staircase direct. In the regulation they say every 3 levels you have to support. But in reality, it depends on the pressure loss of your staircase. Yeah. It works. We work in Germany up to 7 levels with only 1 supply point. Because you have a pressure loss. If you have here a big staircase, then you have a pressure loss maybe of 1 Pascal per level. So 7 levels, let's say 7 to 10 Pascal pressure loss. Yeah. So you start here with, let's say 35, and then on level 7 you end up with 25. 25 Pascal is more than enough to create 2 meters per second. If you calculate over the area, you minimum need 6 Pascal to create 2 meters per second. The regulation had a safety factor, so they say minimum 10 Pascal. When we work here on level 7 with 25 Pascal, it's more than enough. So that means a supply fan pushes the air, let's say, in a duct. Then it goes into the staircase. You have one function to ventilate this, let's say, with 3000 cubic meter constantly. Because if somebody runs out and some smoke enter here, you push it out. The second step, the door is open, and if you have a high-rise building, you goes up. Because then you didn't have the wind load from left and right. The same with your firefighter's lift. The air goes over the lift, same way out of the building. The main problem is on this construction, the pressure loss from this shaft. Because when we start here with 35, we have here 25, we lose maybe 5 to 10 Pascal over this way. So for this long shaft, then you have maybe 15 Pascal maximum. That means your architect has to create such a duct. But nobody wants to rent a duct, you want to have office. So that means the architect makes this duct as small as possible. This ends up with a fan here who has to compensate at the end the pressure loss. And then it begins to be a little bit tricky. So we can pressure control by dampers. That means this damper means your fan constantly runs full speed and you try to compensate or control your pressure with a damper, open, close. Yeah. The same with your firefighter's lift and also with this extract duct that you also can work with here. That means this runs full and you open and close this one. But a lot of mechanical parts that you have to work with. Alternative, you use a fan. Also here a fan. And you compensate this pressure loss with this extract fan. Or motorized dampers, but with these motorized dampers you get here huge problems to get these in balance, supply, extract. Because if this fan runs, the air goes here You have a high pressure, so you have to open this. If you open the door, pressure fall down, you have to close this, the air goes to this, and then you have to work with these dampers. If you do it without all these dampers, only with speed control, you run up and down with the pressure sensor, this fan, and also this fan, you check the pressure here. It's a little bit more electronic, but let's say in these days all the airplanes also fly by wire, so without any mechanical connection to the controls, it's only by electronics. Same with the cars in these days. So now in the regulation you see they create a room. It's normally 200 cubic meters, very tight. You install a supply fan. These are these motorized dampers that we didn't use, so we close this in the test rig. These are your leakages. We close it because then it's more tough, so we don't need leakages if we have a good speed control on the supply side. Then we have our door, and then the air goes inside the room, that's your staircase, over the door, out to the atmosphere. That's the door. In the lab, you don't use the door, because nobody is staying there, open, close, so this is a mechanical door. You will see why. That's the door. And the second version is supply air, same, without our pressure control damper. We don't use one. You can use it, but we didn't use it on our systems. We say we have no leakages, so it's very tough and hard for the control. If the door is closed, the pressure goes up extremely in a very short period of time. So that means you have to react very fast with your fans. But then we have also here the extract fan on the top. Here in the lab, it's horizontal because the lab doesn't build up a building. This is from the other side. The picture, now open. That's your door. Or alternative, as extract fan, you also can use a roof unit. So you have both options. And now the test procedure. And this is really, let's say, tough, because first you make a functional test. That means, is everything working in time? Functional test means they start here, they open in 1 second. Then the door is open for 6 seconds. Then they close in 3 seconds. Then they wait another 6 seconds, and then start again. That's the testing. So that means 1 second, door open, and also the time plus minus 1 second. So the regulations are really strict. So we made a pre-test, and we let's say 3 seconds is the maximum limit, and we reached 3.1 seconds. So then you lost. Doors open for 6 seconds, plus a half second, then close in 3 seconds, and then wait another 6 seconds, and then you start again. That's the testing. And durability test means this one 10,000 times. So you start this Monday morning, and then they work, open, close, and then you arrive on Friday, and then you get the result, yes or no. Yeah? That means in that short period of time, your fan runs from low speed, high speed, low speed, high speed. And when you look on a motor data sheet, how many starts and stops are allowed normally? 6 to 10 starts per hour. Here we have 1 second, 6 seconds, 3 seconds. That means in 10 seconds we go up and down, or let's say in 60 seconds, and then again, 10,000 times. If you survive this, then again, function test looks like this. Up and down. So I come back next week and we are ready with the test. No, it's only for 1 minute, but it's long enough. This is the door here. This was a long 1 minute, but you see, open, close, open, close. After that, you have to check again, functional test, and then that's also a tricky oscillation test. That means you check if you are able with different times, open, close, that your system run in, let's say, in out of time. Yeah. That means it goes in different circles 20 times up and down, and number 21 must be then in the line of maximum 3 seconds. So that means what they do first, they open and close 20 times each 3 seconds. And then they look if the system runs in a resonance. Then they do the same with 2.5 seconds 20 times and check. And number 21 must be in work. Then 2 seconds, 1.5 seconds, and 1 second. And if you only have a supply fan, that's easy and simple. But if you have a supply and an extract fan, and they're working independent, and you did not set up the system correctly, then the doors close, then the doors open, and then maybe the supply fan is too fast, and the extract fan is too slow. Then the supply fan reduces again, the extract fan starts, then the negative pressure is too high, and they're working against each other. So on the control side, it's really, I will not say complicated, but you have to set up it correctly. Otherwise, one of these versions will not work. This is the timing from people who escape. So many people, one after the other, maybe the door opened and closed in 1 second. Or people are a little bit more distant, then maybe it's 2 or 3 seconds between each person. And therefore, these are the tests. This is a copy from the computer there, from the lab where we test. There's a build-up from the regulations, this one. They count the numbers. Here we add number 70, 80. There's up and down. And then you see the pressure and also the volume. See the door open, close, and that's the last 19 and 20. And what you see there, these are the door, open, close. This is the required volume, plus minus 10%. This means this yellow and this yellow, between these two lines, the volume must be there. And also the pressure at the end, when the door closes, the maximum time is 3 seconds. That means the door closed completely. You see the pressure peak. And here's the time. And here's the pressure, plus minus 10%. And at this point, between doors closed and here, we have 1.8 seconds reaction time. That means we are below the 3 seconds, so that's a really good result. And at the end, I will give you one figure where you can check if your system or if the system reached these 3 seconds or below or not. Because it has, let's say, a direct function between your weight from your impeller, from your blade, and the motor power. So if you have a Ferrari, 0 to 100, 3 seconds, no problem, because the motor is strong enough. If you have 30 horsepower, Volkswagen or whatever, you need maybe 10 seconds. So this relationship, there's one figure that you see later, then you can directly see, does this system fulfill these rules? So a short summary. System and the motor must be suitable for 10,000 times, open and closed. Also, every part that controls the pressure. So the motorized dampers must be also with tested. So in the system, everything will be installed and tested that regulate the pressure and the volume. The second, normally if your fan can ramp up and down in 2.6 seconds, then you will fulfill the regulation with the 3 second rules. That means you can compare your motor power in kilowatt to the inertia of the impeller. If this is higher than factor 7, then it's okay. Then you have enough motor power to increase or decrease the fan. That's really important. If it's below 7, no chance. Then your motor power isn't strong enough. Your controller has to be stable in 0.4 seconds. Because then you 2.6 and 0.4, then you will fulfill. We can go back, you can see it here. The pressure goes down, and then you see normally they goes a little bit up and down. And to control this is the most difficult thing, that they didn't jump over the maximum plus minus 10% in pressure or volume. So also you shouldn't go too much down. If you are below there, then the time starts here again. Or if you are here over, then this is the time, then you fail. that means total reaction time 2.6 plus 0.4, maximum 3 seconds. And your extract fan must be tested before to 12101-3 as a smoke extract fan. So then you have two things. First, you have to test your extract fan, F300, F400, depends on which temperature your building has. Normally you use Springlot, F300, not Springlot, F600 or F400. And then this fan also must be strong enough to fulfill this 3 seconds rule. Part 13 shows for the testing at site 5 seconds. Why do you have 2 seconds time difference? The reason for that is, if let's say you have a staircase 100 meters high, then you have a volume inside the staircase of air of 100 meters. The air, the volume has a weight, and you have to stop the complete velocity from this volume of air. And this takes around about roughly 1 second. 1 second, 1.5 seconds. That means your system stops the air after 3 seconds, but also the air you have to stop. This is, okay, I go a little bit back. What? Okay, I'm good in time, so I can explain a little bit more. I have some pictures but the pictures are on the extended version. George has the extended version, so you have to contact him tomorrow, not today, because today he is. If you have this, gives you the main problem, especially in winter when you have temperature differences. Let's say inside 20 degrees, outside 0. Then you have here a chimney effect, a stack effect. If the door closes here, then this air wants to go out, and you have to stop it directly with this motorized damper. This damper must also be tested under part 6 inside. Yeah? But now you have the regulation here, 3 seconds. To stop this volume, this damper must be closed in 1 second. And also it must be a high temperature version. And it's really difficult to find a certified product that closes a damper in 1 second. That's the tricky thing. This one in combination with the fan, because the fan could not work against the closed damper. Otherwise you will destroy the damper when it's closed. So this combination has to work also very well. On 100 meters, we checked in Frankfurt a building, it's 24 levels, so 102 meters. In winter, a pressure difference between plus minus 80 Pascal. So in the middle we have 0, we have here minus 80, plus 80, the air goes up, and on the ground minus 80 Pascal. So the trick on the supply side is then we have to bring in the supply air to different points. And you have to use the pressure loss from the staircase to destroy the stack effect. Yeah? That means in winter you have to bring much more air here on the ground level, and then the air goes up, and the stack effect will be reduced by the pressure loss of the way. And in summer, it's the opposite. but the opposite, the effect isn't so tough as the winter effect. So now we can go back. A little bit physics, but that it is. So that means at the end, extract fans must be tested to the part 3. And that's in time, I hope. Thanks for your time. If you have questions, either now or later. Now, okay. All one is stopped, so I don't have any.
Do anyone has questions on the presentation of Reiner meet?
So just to be more clear what we understand it here. In the previous version of the yen, and also in until now commission that we made, it was announced to have the 3 seconds, the fan, to be switchable. But we do not measure the 3 seconds. We usually measure the volume, the pascals, the pressure, and we measure also the 2 meters per second. So is in this new version of yen, we have to go in commissioning to add also the measurement of the reaction of the fan in 3 seconds or in 5 seconds.
Yes.
Yes.
Yes. But this was also still in the old regulation.
It was?
Yeah. So let's say TÜV or DEKRA in the building, they open the door, 1, 2, 3, check the velocity.
Yes.
That's okay. Close the door and say 1, 2, 3, and then they check the force to open. And if it takes 4 seconds, okay. In the new regulation, they allow up to 5 seconds. Yeah, but let's say 1, 2, 3, 4, 5, and then 100 Newton maximum.
It's just the clarification if it's only for the test or also for the reality.
For the reality.
Okay, good. Okay. Thank you.
Thank you. Do you have any other questions?
Yes, hello. Is it possible to control the damper that we need to react in 1 second only? Would be a pneumatic system, or do we need to be only electrical one?
The pneumatic system is more difficult because on the high temperature F300 you will fail with the pneumatic. But we have 2 versions in our program. Let's say we started with testing with a specialized motor, let's say from the chemical industry. It has a reaction time of 0.8 seconds, but it costs 800 euros each motor, so forget it. So we use now, we have standard motors from with 1.2 seconds, but 1.2 seconds is fast enough. Yes. Yes.
Thank you.
Thank you very much. Any other quick question? Thank you, Reiner. Thank you very much.
Okay.